So now we need to talk about the sine conventions that are used for mirrors. We have these equations, and these equations work for any mirror and any lens, but they only will work if you get the signs of these numbers worked out correctly. For a mirror, distance to the object, always positive, it's never negative, okay? The height of the object, again, it's always positive, never negative. Distance to the image, if the image is in front of the mirror, so on the same side as the object, this is what we had for a concave mirror, then the distance to the image is positive. If the image is behind the mirror, as it was for the plane mirror, the distance to the image is considered to be negative. So the front side of the mirror for the image is positive, the back side of the mirror is negative. Then the height of the image, if an image is upright, then it's positive. Okay? If an image is inverted, then that'll be a negative number. Focal length for a concave mirror is a positive number. Focal length for a convex mirror is a negative number. And then the magnification, if your magnification is positive, then your image is upright. If your magnification is negative, it's inverted. So use these conventions for the concave, convex, and plane mirrors, and then these equations will work for you. So now we're going to try ray tracing with a convex mirror. So this is a convex mirror. The focal point is behind the mirror. The center point is back here, so the focal point is half the distance to the center point. I've given it a scale so that this distance right here, 0.3 meters. Now remember, it's with a convex mirror, that's a minus f. So f is a negative number. Distance to the image, I put it one and a half of these boxes away, so 0.15 meters. Okay, so now to draw it, we need 2 out of the 3 principal rays. So first, I'm going to try the parallel. So if I draw a parallel line here, so from the image, the parallel ray goes right there until it hits the surface of the mirror. And remember, the parallel ones are the ones that point directly toward or away from the focal point. So from the focal point, I go here, and the light ray will actually go up that direction. Or you can extend it behind the mirror. It's not really going there, but with a dotted line back to the focal point. So that's one option. We can also get to the center line, center point. So my ruler is not quite long enough, but it's something like this. So the center ray will go straight toward the mirror, bounce straight back. But we can make it a dotted line, so a virtual line of light going back there. The other one that we could use goes straight from the top of the image to the focal point. So it goes down like this, and since it's heading straight toward the focal point, the real light will come out here parallel, like that. And so virtually, it gets dotted lined back to there. And you can see all 3 of them went to the same point. So if you've drawn it correctly, you really only need any 2 of those. So the image sits here, right like that. And then we can use the equations to figure out height, distance, and magnification.